This lecture is about avoidance. And if you recall, avoidance by its procedure has an aversive S2, that means something like shock, a negative R1 S2 contingency, which means that when the target response happens, the S2 does not happen. If the animal fails to do the target response in the presence of S1, in the presence of the initiating stimulus, if they don't do R1, then S2 is provided. R1 goes up in avoidance. It makes sense. The animal learned that if it does behavior, in a sense, it doesn't get this aversive event. This is also known as negative reinforcement. An aversive stimulus is avoided in this case. So let's use some of my horrible animation again to show you what this might look like. Oftentimes avoidance experiments use what are known as shuttle boxes, which means that the animal goes back and forth. Light comes on, animal jumps to the other side, and there's a shocking grid here, and you saw the animal avoids the shock. Again, the light comes on, animal jumps to the other side, and the shock happens where it was, and it doesn't receive a shock. It avoided an aversive S2 by doing the target behavior of jumping to the other side. And there's a lot of different types of these apparatuses. You can use it for dogs. This one is used for mice. The animal runs back and forth under here. You can see right here, here's the light. Also, sometimes tones are used. And if you look at the bottom, there's a shocking grid where an aversive S2 is provided if they don't run across. But here's the problem. Here's the paradox. We need to fit this in with ideas of the SR reinforcement principle, also known as Thorndike's theoretical law of effect, or classical conditioning, or something. How can the non-occurrence of an event, like shock, the absence of something, serve as a reinforcement for a response? Remember Thorndike's theoretical law of effect? SR connections are formed when what follows is good. That's how connections are formed. When what follows is bad, it reduces that connection. That's according to Thorndike's theory. We get into some other theories dealing with of punishment. But in this case, the target response happened, so the animal would receive nothing. The light comes on, S1, the animal runs across, R1, and then it gets nothing. That's paradoxical. We need a reward. We need to find ourselves something rewarding. How can nothing be rewarding, right? So this kind of gives problems to Thorndike's empirical law of effect, meaning behaviors continue when they're rewarded, and theoretical law of effects, which says SR connections are formed when what follows is rewarding, when what follows is good. Okay, so what we need is what's known as a two-process theory. This is Mower's two-process theory, also known as Mower's two-factor theory. Two things must happen in order for an animal to learn in avoidance. The first in the two-factor theory is classical conditioning. The animal must first experience classical conditioning. Fear, in this case, is classically conditioned to the environmental stimuli that occur prior to the aversive event. In other words, in an avoidance, at the beginning, the animal has to take a few shocks, and that light has to be associated with shock. The second factor is instrumental conditioning. First is Pavlovian, second is more Thorndikean. Instrumental conditioning occurs, running across, followed by a reward. In this case, a reduction of a conditioned aversive state. The animal is running away from that light because that light makes them scared. And when they get to the other side, they have less fear, they feel better. Anytime you improve an animal's state of being, that's a reward. It was fearful. Now it's not fearful anymore because of its actions. In essence, the animal escapes fear and in the process avoids getting shock, but doesn't avoid an aversive stimuli, it escapes one. So back to my animations. So at the beginning of an avoidance experiment, we start off, the light comes on, the animal gets shocked. It doesn't know it's the first trial. It doesn't know anything about the light. So now the light has been presented in temporal contiguity with the shock. So now the light comes on, and the animal's shocked again. We have to do this a few times. That's what conditioning is. That's what classical conditioning is. And now, after a few times of the light coming on, the animal's getting shock on its foot. The light comes on, and it escapes the light. It runs away from light, just like any animal would. Animals escape or run away from things that cause them fear. So when the light comes on, it simply runs to the other side. And when it gets to the other side, it doesn't see the light anymore. The light's not on anymore. Oh, it feels so much better. It's rewarded for its action. Oh, sure, it avoided the shock. It did. It avoided getting shocked. But really, it was rewarded because it escaped the light. Light comes on, S1. R1 is run away. S2 is feeling better, feeling less fear. And that creates a connection between seeing the light and running from it. So some testable features about Mower's two-factor theory. We know that in other types of motivations, the light produces fear responses. We can measure those things. The animal is fearful. We see some freezing behavior before the animal runs away. We see some increased activity that resembles fear. So we know that that light has been associated with something fear, an aversive emotional state, or motivational state in this case. The state is classically conditioned through the contiguity of the CS and the US. Light comes on, the animal shocked. Light comes on, the animal shocked. Light comes on, the animal shocked. We do that a few times, and now we've created that conditioning. And then the instrumental responding can be strengthened if we terminate the light. So if the animal runs to the other side, and as soon as it does, we shut the light off, learning is even faster. It's even stronger. If the animal goes to the other side and the light's still there, it's very difficult to teach an animal to avoid shock. There's some problems with this sort of very convenient, easy way of looking at avoidance. I mean, this idea of, we just classical condition and then we instrumental condition and we're good. This may not be as direct. One, it's hard to extinguish avoidance behavior. If fear is classically conditioned to the CS and the light comes on, produces fear, runs to the other side, what we just did is an extinction trial. Light comes on, animal runs to the other side, does not receive the shock, and for that trial, the light and the shock were not paired. That's extinction. And now it's on the other side. Light comes on, runs to the other side, and it feels better, but we just had a second extinction trial. What we would expect is that after a while, the light no longer produces a fear response. Whether Pavlovian in terms of inhibition is created, or Rescola and Wagner, the decline of excitatory association. Either way, what we would expect in this is for the light to come on, the animal gets shocked, several trials. Now it's scared. Light comes on, runs to the other side, feels better. Light comes on, runs to the other side, feels better. Light comes on, runs to the other side. All those trials now are extinguishing the light and fear association. So we would think after a while, light comes on, the animal's like, I'm not scared of that light anymore. And then it gets shocked again because it didn't avoid. But we don't tend to see that. In research, we tend to see avoidance being a very difficult thing to extinguish. The presence of the CS and the US, the fact that they aren't paired after a while, doesn't seem to diminish the animal's ability to show avoidance. We also see that the light does not produce fear responses in other circumstances. So let's say we're just something very similar to condition suppression. Okay, let's say we're doing an avoidance experiment. Light comes on, the animal gets shocked, light comes on, animal gets shocked, light comes on, animal runs to the other side. And we do that over and over. What we've just assumed, according to Mower's two-factor theory, is the light is associated with fear. We have some evidence for that, but what's weird, it's only in that context. That seems odd, because if we then use the exact same light while the animal's pressing a lever to get food, like, pressing lever, get food, pressing lever, get food, and we turn on that light that we used in the avoidance experiment, it still presses the lever a lot. In other words, it doesn't look at the light and go, oh, I'm really scared of that, I'm going to stop pressing the lever. So it doesn't seem to follow all the exact same rules of classical conditioning and Pavlovian conditioning. Mower's two-factor theory is a good theory. There's just a few weaknesses. So now we get into what I consider to be a really hard experimental design to understand. Not only the experiment itself, the procedure, but how to explain it theoretically. This is known as Sidman avoidance, or Sidman's avoidance, because it was developed by a researcher named Sidman. And in this case, it's non-discriminatory free operant avoidance. It's a big name. So let's go over the procedure nice and slowly, and then we're going to tell you what happened, and then we'll try to figure out why. So here's the procedure. The animal has to press a lever, like in an operant chamber, has to press a lever. And if the animal has to press it after a given amount of time since the last response, or it gets shocked. So if it doesn't press the lever at all, it gets shocked. If it presses the lever, it gets a time of reprieve. It doesn't get shocked for a bit of time. So the poor little creature is shocked every 10 seconds. However, if it presses the lever, it doesn't get shocked. A timer is reset for 30 seconds. So if it pressed the lever a lot, it would never get shocked. If it was a perfect situation, it would press the lever every 29 seconds. And it would be fine. Never get shocked. And they learned to do this. I will say a couple things about this. One, it's very hard to train a rat to do this, but they can be trained to do it. And two, there's a great deal of variability in how the animals respond. Some animals pressing levers a lot. Some are showing a lot of variability when they press a lever, and some just can't learn it. So this is a difficult thing. But the issue here is we don't have this really salient light shutting off, right? Mower's two-factor theory makes a lot of sense. Light comes on, the animal is shocked, we have this really salient light and shock, and they come together, and he goes, okay, that light produces fear, and I'm escaping the fear. It makes all sense. And it's even better if when the animal runs the other side, the light shuts off. Oh, great, the light went away. I hate the light. I feel so much better. We don't have that in Sidman avoidance. It's a really difficult thing. In other words, animals are able to show avoidance, press the lever to avoid getting shocked, in the absence of a salient kind of means bright or attention-getting CS, and yet they still solve the problem. So here's how we're going to try to understand it, or how people have tried to understand it. Could be understood as the S1, the initiating stimulus, the stimulus that is connected to the behavior of pressing the lever, is the discrimination of time. We've talked about time a little bit. We're going to have a whole lecture on time and time perception. But in this case, time since the last shock or passes by and the animal can perceive that. Animals tell time, not perfectly. but they can perceive the passage of time, and that can act as a stimulus. So here, picture the animal. It just got shocked, and it presses the lever. And by the way, they have to do this for a long time. This is training over days and days and days. Presses the lever. Right after pressing the lever, it's not going to get shocked. It's learned that. It has some time. Right after pressing the lever, it's going to feel pretty good. It's going to get rewarded. We'll talk about that in a second. But now it's been 10 seconds since they pressed the lever. And now it's 20 seconds. And now it's 25 seconds. And what happens is we get this welling of fear as that 30-second time approaches. That's different. There's a different state in the animal. It just pressed the lever. It feels great. Now it's been 20 seconds, 25 seconds since pressing the lever. That's different. I'm feeling a little scared. Little rat's feeling a little scared. And that could act as an initiating stimulus. The reward is not salient, but it might be something the animal can detect, and it could be a feedback from the R1. So let's picture this animal. He presses the lever, presses it. That's a tactile thing. That's a stimulus. It can feel that. Has it ever felt pressing the lever, a feedback from pressing the lever, a feedback from pressing the lever, which is R1? Has it ever felt that and been shocked? No. It presses the lever and it feels good. And that could act as a stimulus that tells them, hey, it's okay. You're going to be okay for a while. So now we're going to introduce kind of a new concept that they talk about in Sidman Avoidance. That's known as the SR1. A stimulus, stimulus, that represents feedback from doing the R1. What's the R1? Pressing the lever. What's the R1? It's pressing the lever and feel it on the animal's hand. Wait, animals don't have hands. Well, I guess monkeys do. Apes. Rats have paws. Feeling pressing the lever on the paw is a feedback stimulus that tells the animal, you're going to be okay for a while. You should feel good. Can you imagine being in this environment? This is not a pretty experiment. The little animal's getting shocked every 10 seconds. You're not using 3 amp shocks. These aren't things that are causing a great deal of pain, but it's not feeling good either. It's a very anxious state. This environment is very anxious. There's lots going on here that are harmful. But when it presses the lever and it feels the paw pressing the lever, okay, that's a time to feel okay. That's a time where they're rewarded. So now we have to use this really odd diagram to try to understand this. So S1 is the lever, the sight, the being in the cage, the sense of time passage, which is not very accurate. This is one of the reasons we get so much variability in performance. But if I see the lever and time has passed and I don't do anything as a little rat, I get shocked. So we have classical conditioning here. The animals, by the way, in Sidman Avoidance, they're not very good at this. They will learn to press the lever. They'll solve this problem, but they take a lot of aversive S2s, a shock, and even if they get pressing the lever a lot, they still aren't very good at it, and occasionally they're going to get shocked. So feeling time since the last time the animal pressed the lever is associated with shock. However, if time has passed and the animal sees the lever and it does the target response and it feels that stimulus, that feedback stimulus, that tells them they're going to be okay for a little while. That's rewarding. That stimulus is rewarding, and it helps to create an association between S1 and R1. Thorndike's theoretical law of effect, also known as the SR reinforcement principle. Not a very salient feedback. Boy, it'd be a lot better if we gave this animal a big giant hunk of cheese. That's super rewarding. This is just, I feel a little less anxious for a bit of time. Rewarding, but not the most salient reward. Another way of looking at it, really, is classically condition inhibition. That's what's going on here. When the S1 is by itself, there is no feedback from the pause. There is no pressing the lever. When it's just by itself, when stimulus 1, the time passing and the lever, the side of the lever, the animal gets shocked. But never when the time has passed, S1, and they have a feedback from the SR1. In other words, they just press the lever and they feel it. It's a salient, pressing lever, kind of salient. I mean, it'd be better if we had something else, but they never get shocked with that. Time passing without lever pressing, shock. Time passing with lever pressing, no shock. A plus, A, B minus. It's conditioned inhibition. And what is this telling them? In this case, the US is shock. It's not good. In this case, a conditioned inhibitor makes them feel great. Now, we've done experiments and talked about experiments where we do it with auto shaping in food, and the conditioned inhibitor tells them they're not getting food, and that's a bad thing. But in this case, the conditioned inhibitor is good. What is the conditioned inhibitor? That could be a question on an exam. In Sidman and Avoidance, to explain Sidman and Avoidance, what is the conditioned inhibitor? That'd be a hard question. But it's the feedback from pressing the lever. They feel it. They feel it on their paws, and that is never followed with shock. If time passes and they don't have that stimulus feeling on their paws, they're going to get shocked. The SR1, not the most salient stimulus. Animals don't do well on this, but they do solve it. We can get rats to press levers to avoid shocks. If we add something, this is just to show you the theory is kind of right. If when they press the lever and they feel the pressure of the lever on their paws, soon as they do that, they hear a bell. Ding! So not only do they press the lever and feel the pause, but they hear this very loud, salient ring. Bing! So in this case, time passing and they don't do anything, they get shocked. Time passing and they press the lever with their paws, but they also get this thing we call a safety signal, which is like beep or bell or something. That is really salient, and we find by adding this thing we call a safety signal, this is simply noise, a bell, a buzzer, or something when they press the lever, they do better at this. They avoid more shocks. In other words, that bell that they hear is really salient and acting as a conditioned inhibitor for shock, and they're like, yes! Oh, I feel so much better. I'm so anxious, and now I feel better. At least for 10 seconds, 20 seconds, I was feeling better. 22, 24, 25, I'm feeling a little nervous. That's the S1. I press it again. Ding! Oh, I feel better. So here's some factors that can influence avoidance learning. The severity of the event. So the more severe the shock, that can lead to faster learning. To a point, right? So a very mild shock, you're going to get avoidance a little bit more. Intense shock, you're going to get the animal learning avoidance more quickly. There is a point when if the shock gets too intense, the animal just kind of freezes and doesn't learn well. The delay between the presentation of the feared object, light, and the aversive event, if we increase that delay between the two of those, we're going to probably get a little slower learning. Okay, so there's also been some ideas about avoidance as being a special way of learning, a special type of learning, especially for prey animals. And we call this sort of the predator defense and avoidance behavior. This is innate, that it'd be really good if animals learn very quickly to avoid predators, right? That can be very dangerous. May have evolved special types of learning. This is controversial, by the way. This is saying, well, there's something other than Thorndike and Pavlov going on here in avoidance. And so we get what's called the species-specific defense reaction. This is specific to certain animals, especially prey animals. Responses by members of a species to aversive stimuli prior to experience. So we can talk about things like an animal's preparedness to be fearful, or reactivity, which is an innate response to fearful events, like freezing and fleeing and fighting, that the animal doesn't necessarily have to go through this trial and error learning. Trial and error. That's what we're showing with the avoidance. Light comes on, the animal takes a shock. Light comes on, the animal takes a shock. Light comes on, animal goes to the other side. Trial and error, just trying things out. And what the idea was is that maybe some animals come to the world already with the ability to sort of learn avoidance without the experience. Again, it's a little bit controversial. These are innate responses that may increase the rate of learning in escape and avoidance. In other words, evolution shaped an animal to be able to not have to go through trial and error learning. So what the argument is that trial and error learning in avoidance doesn't make a lot of sense when we're talking about predation, right? So a little rat is running along and passes by some trees, and a lion jumps out and eats the rat. That's you can't have trial and error learning, right? You can't say, oh, I have this adverse event, I need to learn to avoid those trees. One trial learning here might end up being a dead rat. So the reason that this idea is put forward is to say that some animals must have an innate ability to learn to avoid, or learn really quickly. Maybe it escaped predation and it learns to avoid very quickly, because trial and error learning would not be an evolutionarily stable strategy. In other words, that would make the animals not survive very well.